All right, so as you see here, our first equation, right? We had y equal to 3 minus 2x. As I mentioned, at the very least, just plug in points. So intercepts were mentioned first, so that's why you see me plug in 0 for x right away. We talked about plugging in 0 for y and the work that came with that. I pushed and just said, hey, if you plug in 1 for x, you could do it by looking at it and doing the work in your head. That was my only option there. Whatever you're comfortable with, those is the key. All right. As we go to the second one, though, what's different about how this equation is written when we compare it back? The y is not by itself. Everyone sees it's not solved for y or x. This is going to be what we call either standard or general form. This particular one is standard form because the 15 is by itself. Right? Now, the one thing I will say is when you get in this form, you could do the work to solve for y. You could definitely do that. And then take the approach that we just did, using slope and intercept. But no, as you look at that, does 3 divide into 5? Or does 5 divide into 3? So we're going to have a fraction somewhere to do. Is that clear to everyone? So if you don't mind dealing with the fraction, you'll be fine. This is one, though, where I would say definitely use those intercepts. Right? Break it into the 2 intercepts, because at that point, we would have 2 values that we're working with. We cut it in half and say, hey, let x equal to 0. Then let y equal to 0. So we can see what this work looks like. So if we let x equal to 0, the nice thing about that, anything times 0 is itself, right? So that term's gone.
You don't set the y, like.
Not at the same time.
You don't do that first?
What do you mean?
Like, the way I did it is I was like, I set it like where to what the y would be by itself, then I did the intercept.
You can do that way, but you don't have to. Hopefully what you see here is I can simplify the work a little bit. It's just to simplify work, right? We should still get the same graph. But I'm trying to show you that when it's in this form, just plug it in 0, that term goes away, right? So all you have to do is division. And you have your point. Now make sure you're careful here to say, hey, the point is 0, -3. I always encourage people to write that out. Which did you get that point? And so we're good, right? So now the other point here that we're going to deal with is if I let y equal to 0, we need to confirm then whatever way we choose that we get the same result. So here we would say 3x equals 15. Where did my -5y go?
The 0 maybe.
Everyone see what I did there? So I kind of feel like if I stated over here that that's going to 0, there's no reason to even add that there. If you want to, go ahead. Because all it is saying is that, hey, I plugged in 0 for y, so -5 times 0 is going to be 0. Oops. Then doing our division, we get 5. Just make sure you remember that 5 goes with 0 for y. Those intercepts actually work out nicely because both of them were integer values, okay? And then from there, we'll just draw our line. Now, with that said, was your slope value in front of x 3/5? How do I know I'm checking for 3/5, right? So since we're looking at graphs, right? The slope is the average rate of change. So if I pick on these 2 points here and say, hey, let's find the average rate of change of these 2 points, we can do a graphic, right? We have to go up 3. And then how far to the right? 5. So the average rate of change would be 3/5. Now, remember as we showed yesterday, when we talked about the average rate of change, I know not everyone liked looking at it, but my whole point of doing this was to show it no matter what linear equation we look at, the average rate of change is always going to be the coefficient on x. That's why we give it the name of slope. All right, not that we're going to have to do this on our own. However, make sure you remember that this was the one I said be prepared to do on your own. Okay. But the other one, I made sure to show you that any linear equation, that's going to be true. I don't know why it's zoomed out like this.
Do we have to write down the fraction?
What do you mean?
3/5.
What I just did?
Yeah.
No. I was just making sure because that's as one person mentioned. clicked the wrong thing, sorry.
But whenever I set it equal to 0. I kind of got stuck at the like whenever you minus 3 from both sides apart, when you have set the y equal to 0. I kind of got stuck right there because I was like, I'm looking at confused.
Yeah, so that's one thing you have to be careful of. So you're saying that you had, if I try to guess, y equals 3/5 x minus 3, you're talking about here?
Yeah, but the 0, the y was 0.
Yeah, so if you do y equals 0, that'll give us 0 equals 3/5 x minus 3. So add the 3 to both sides.
That's fine.
And then here, you could do different things. I personally like just multiply by the reciprocal. Now you can multiply by 5 first, get rid of the fraction.
That's what I was trying to do, but then I think.
So if you multiply by 5 first, just remember that's going to give you 15 equal to 3x. Because that will get rid of that.
Yes, I can.
Yeah, you can. It's just like I said, I like the reciprocal does it one step. You just chose doing 2, that's all.
I was like looking at them, I was like, can I even do that?
But keep in mind, as you did all that work, would you rather do all the work? Because keep in mind, what she's saying is that she chose to solve for this first. Nothing's wrong with that. That's the slope intercept form of a linear. Like I said, you can use that to graph quickly. Right? In fact, what I would encourage you to do for graphing that would be to start at that y-intercept and just say, hey, I have to go up 3 and then to the right 5. And look at that. You didn't even have to do that extra work. You got to the 5. Okay? But that's good to know for everyone. That's why I like this approach. Now, keep in mind, there's homework problems that are going to tell you to find the intercepts, right? And then graph it. So that's kind of where I'm encouraging you to do this approach. That's where that comes from. Okay. Abdul, make sure I answer. You were talking about this fraction here, right?
Yeah.
So make sure, see here, I'm making sure to connect it back to our slope conversation. So like I was showing here that this -2, if I go down 2 and then right 1, those are both solutions.
Yeah, so it's just like checking your work.
Yeah. And to show you that, like as mentioned, if you solve for y, use that to your advantage. Plot your y-intercept and then use your slope. That's another great way to graph. Okay. Now, that's kind of 2 different ways we could see the equations though, right? Whether it's going to be slope intercept form or standard form. They also have something called general form. I believe that your homework had you do that. Just know that means move the -15 over with the x and y. I don't push that one because I think it's more practical to have it set up for nice graphs, right? How can I get this to a place where I can graph it nicely? That's my main focus. Okay. With that said, though, we do have to be prepared for these exceptions. All right. As I mentioned, our context here is these represents equations with 2 variables, but how many variables do we have on both of these? Only 1, right? So what that means is we have to recognize that we had 0 times x on this first one and 0 times y on the second one. So that's why we don't see them. They're not there because they were multiplied with 0. Well, hey, this one's not too bad to work within, and I'm going to graph it in green. Because if that 0x is there, that means my slope is 0. We can correlate that back to say, hey, my slope is 0. And all I'm doing is trying to connect it back to something familiar, y equals mx plus b. If the x isn't there, the slope is 0. From a graphing perspective, this is where having that information is very helpful because then we could say, hey, plot this point first. And what point did I focus on? The -2, specifically the -2 on the y-axis, right? Because that's my y-intercept. From there, a slope of 0, right? It's neither decreasing nor increasing. It's what we call constant. So this would be where we see that anytime we have this, that's going to be a horizontal line. So make sure we have kind of a note to ourselves like, hey, this is horizontal. Well, guess what? X equal to 3 is a special situation. And it's very important that we watch for this because when we get to this second one here, it represents a situation where it's not a function anymore. Right? This is not a function. It's a relation, it's a set of ordered pairs, but it's not a function. So make sure you have in your notes somewhere to yourself, like, not a function. Because what happens is we're gonna plot that point to start my graph at the +3. But instead of a horizontal line, it's gonna be what? It's gonna be vertical, right? Now, why is this not a function?
Because it hits the same point.
The X value is used infinitely number of times, right? That's a special case. Not every line's vertical, right? But in this case, that's what it represents. So make sure you see here, it fails the vertical line test because it is a vertical line. However, it's still a line, right? It's still a line, and we're going to use vertical lines for many different things. One of them is the vertical line test. Focus on particular X values to see what happens. Other reasons, if you remember, we kind of hinted at it. Should I just do this? Another reason that we use a vertical line, that was the vertical line test, right? Is some of our graphs have some restrictions that create some different patterns, right? And if you remember here, I used this vertical line to say, hey, we cannot use 0 ever when it comes to division of a variable. All right, now, hopefully you remember there, I plugged in points to kind of show the behavior, and we'll talk about it more as I mentioned when we get to rationals. But that's an example of where a vertical line is important, right? That vertical line is X equal to 0, but I put it as a dotted line to show it's a vertical asymptote. It's not a part of my graph, but it impacted my graph, okay? Now, the good news is we're not dealing with that aspect right now. We just want to make sure to recognize, hey, that's a vertical line because I do not have my Y value. And since I'm talking about a relation, that means all my ordered pairs better have 3 for X. Doesn't matter what Y is, because as long as X is 3, I'm good. All right. So as you look at that one, you can leave the not a function aspect, but make sure you're saying that, hey, this is my vertical line as well. Questions or concerns there? All right, so we can build tables, right? We can find intercepts. Those are great things as far as working and getting graphs. Oftentimes, you're going to find we focus on intercepts quite a bit once we get past linears. With that said, the other thing that I hope that you kind of took from this, though, is talking about how important the slope and y-intercept, the slope and the y-intercept. Okay, so that's where these next problems come in. All right, this is what we're going to see here is we're going to begin to have a situation where we have a graph and we need to find the equation of that line that we see. So right now, instead of giving you the graph, I just gave you the information that, hey, this graph, what's true about it is the slope is 3/2, the y-intercept is 1. Okay. And these different situations represent different graphs. I think I have 4 in total, right? So with the first one, though, we want to write out the linear function. With that said, typically we're going to have it in that slope intercept. Usually that's what's going to be asked for, slope intercept. But do know, as we, like I know a couple people messaged me on the homework, there's other ways to write it. But for my test, I'm going to say, hey, write the equation of the line in slope intercept form. All right. So as you look at this first one here, what do you like about the fact we were given M and the y-intercept? All right, so we can go straight to y equals mx plus b, right? What is the b value again? It's the slope is my 3/2, right? So that'll be 3/2x, and what goes after that? So that means whenever you have a y-intercept, that y value is our b, is the key there, okay? So if you have the slope and y-intercept, hey, you have the equation. You don't need to do any guessing. It's there. All right, what I do differently with the second one?
What? Well, it's kind of the same.
It's kind of the same, right? I gave us the slope still, but I wrote the solution as an ordered pair, right? Well, be careful to remember that. Watch what ordered pairs you have, because I gave you an ordered pair the first time. I just made sure to call it the y-intercept. So technically speaking, we could write this out right away. But make sure you see with part C, we do not even have a slope. So we have to be able to talk about what happens when I don't have a slope, okay? So we talked about like different ways to write the line. So you could have the line in slope intercept form. You could have the equation in standard or general form. But another useful form for lines is going to be what we call point slope form. All right, point slope form is definitely something we need to be comfortable with. If you get stuck, you know, I'll let y'all have the 3x5 card on the next test as well. All right, but just look at here, instead of division, it's multiplication. And if you look at it, it follows the same pattern of the slope formula. The big difference here is we change it from division to multiplication, but we want to keep these as y and x. We do not want to plug in for them. That's what's going to give us our equation. Now, why is this helpful? All right, well, guess what? We can take the information we were just given and plug it in to do the work. All right. What that means is, though, we're going to have to distribute this -5. And then I can add the 7 to both sides. And guess what? Isn't that the equation we started with right away? You didn't have to do this for this problem, though. Make sure you see that if you recognize you have a y-intercept, you know your equation. Okay, if you have, once you have a slope and once you have the y-intercept, you have everything you need. This is just another tool, as you'll say, to help us get there. Just a helpful way to write. But this all goes back, like I said, to the average rate of change and the fact that for linears, the average rate of change is a constant value. It doesn't change how it behaves, okay? Now, the reason I give it to us, though, is because as we go to part C here, I'm given 2 solutions, right? There's no slope in it. And neither of those are intercepts, right? So I have to actually go in and do the work to find all of that now, right? So the 2 things we need, make sure you caught on to that. The 2 things we need are a slope and a y-intercept. That's what I wanted to put in with those first 2. Once you have your slope and y-intercept, you have all the information you need to write the equation. So over here, what's the one thing you can get right away once you have 2 points? You go get the slope, right? If you have 2 points, you got access to the slope, because remember, again, it goes back to that rate of change, right? The slope formula states that m equals what? I hear someone whispering. Change in y over the change in x, right? Now, does it really matter the order of that we put the plug in the order pairs? Which one goes first or second? The only key is these 2 values better come from the same ordered pair, whatever order you choose. What we're going to find here, though, is that this will give us 11 minus -5 all over -5 minus 3, which would be what, 16 over -8? Right, that one's nice. Now, keep in mind, it's not always going to work out. As we saw, we can have rational slopes, but here we get a -2. Now, at that point, we have our slope. What was the other thing we need? Our y-intercept, right? Do I have a y-intercept right now, though?
I mean, no, but.
So I can use point slope form, right? Now, there's different ways to do this, right? As long as you remember y equals mx plus b, you can plug in and solve for b, right? I personally like the slope formula, point slope form, because that means you already have the information all there ready to go. So this would be minus -5 equal to -2 times x minus 3. I plugged in the slope and I plugged in my first point. That's the equation of the line. You have the equation of the line. So say it's a test, you get here, technically you wrote the equation of the line. From here, it's just putting in the form that I request. Because as I mentioned on my test, I'll be like, hey, write it in slope intercept form. I will be specific about that. Okay. So with that said, though, we do need to solve for y. So change our sign on the 5, distribute the -2, and then lastly, subtract the 5. And at that point, we have all that we need. What is the y-intercept? Once we get there, just make sure you remember that, hey, if I'm asked to graph it at that point, I have my y-intercept and I have my slope. Any questions with that one I can help? Someone feel more confident about? Now, at this point, there's some things you do need to remember. At the very least, you need to remember this. And slope intercept form, right? The thing that I said was helpful is to make sure you know point slope form. I think it makes it a little bit more straightforward as far as plugging in and just know once you're done, once you simplify and then move over that y value that you had, you're good to go. But it is your choice. There are other ways to do this. Okay, so keep that in mind. But let's look at it for this last one. And I have a couple more things that kind of special cases we have to watch out for. So once we get here, the thing that we have to realize is that I need to assess the situation and just make a decision. Some of the key words that we have to make sure you watch for is like here I said, find the linear function. Or if it says something like given the graph of a line, once you see linear line, that's how you know that, hey, I'm focused on something specific. And it's important that we highlight that because when it comes to the final, this won't be the only function that it might ask you to find. It could ask you for a line, it could ask you for a circle, and it can ask you for the equation of a parabola or a quadratic. Okay, those are some examples where once I give you information, you need to know how to get to that equation or of the function that is. So once you see linear function, that's how you know that, hey, these are the things I'm focused on. That goes with the linear function. In fact, this is really the way I want to try to write it when I can. Okay, so with that said, I don't have anything I need right away. I don't have an intercept because no zeros there and I need to get my slope in. All right, so what you need to make sure to remember then is once I have 2 points, I'm probably definitely going to at least use the slope formula. Then the only thing I encourage you to do with that is just remind yourself, hey, that's just the average rate of change, the change in y all over the change in x. And the way we find a change is subtraction. That's how we find how much something changes is through subtraction. The key here is you have to remember is y goes in the numerator, x goes in the denominator. Okay. Well, what's that give us? 6/8. And I can simplify that out by dividing out some 2's. So 3/4. The last one was nice because it was -2, but now we have to do a fraction. But no, guess what? That's something you're gonna have to deal with when it comes to linears, is dealing with the fractions. Okay. Once you get here, as I mentioned, there's different ways to solve it. My preference, though, that as far as teaching is concerned, is point slope. And one of the reasons I like it is make sure you see that it's not something completely different than what we're working with. All we took was this division and changed it into multiplication. The denominator has to be multiplied with m though, because it's got to go to the other side of the equal sign. The key is to remember, do not plug in for y or x. We want to keep those. Right? And it's better to keep the first one because then that subtraction is a little bit easier to work. So that way your y is a positive 1 right from the beginning. With that stated though, we can go ahead and plug in our first point that we were given. So it'd be y minus -3 equal to 3/4 times x minus 5. Now here's where the fun comes in, right? Because we've got to deal with that fraction. We'll have y plus 3 equal to 3/4x. And then here we can't simplify, so just remember multiply the 5 with the 3. So it'll be minus 15/4. Now, am I done at this point though? Oh, now we need to go deal with moving this 3 over here, right? But keep in mind, what am I going to need to combine this 3 with that 15/4? Common denominator, right? My common denominator is going to be 4, right? So what's 4 times 3? All right, so as I go through this, it'll be y equals 3/4x minus 15/4 minus 12/4. Remember, 12/4 is still 3, right? So I subtracted the 3 from both sides, but we needed the common denominator. So we'll get to the point where we could actually do the addition there. Just be careful that, yeah, you're adding the 12 and 15 together because they're both negative. Make sure you keep it negative. That is one thing to be careful. Now, is every problem going to have fractions? We got to find a common denominator? Not at all, right? So keep that in mind as well. Any questions with that?
So whenever you got 15/4, you multiply the 3 and 5 and then
Yeah, right, because remember with that, what we're doing is just reminding ourselves that, hey, that's 5/1. Which I did kind of the same thing here, right, with the 3, but I wrote it as 12/4. So it's kind of a similar thing. Just remember whenever you have that, hey, anything over 1 is itself. It's definitely helpful. Now, with that said, there's a little bit of work with some of these, but hopefully what you're seeing, it's more about remembering the formulas, right? Which for this face-to-face class, what did I say we can use? All right, you can add that note card. So that's something I definitely encourage you to start making sure to highlight the things that you should have on. Quadratic formula, still need that. Slope formula. Point slope form, right? What are different ways to write these equations? Okay. Now, with that said, though, we do have some cases that we do need to look at that we have to be aware of. So as we deal with these are going to be your special cases. Most time it's like one problem because there is going to be a lot of different things on this test. So just a heads up.
Oh, what is the
We have a midterm?
We have.
I'm asking you. You didn't read my syllabus, is what you're saying. Ah. Anybody who read the syllabus? Anybody print off the schedule? No one.
I got to read that, but
Is there anything about a midterm on there? There is midterm week, right? But we don't have a midterm. I think week 9 is our next test. So not next week, but the week after, if I remember off the top of my head. So not next week, but the week after. Okay. That's midterm for us, but keep in mind, that's just another test. We don't have a midterm. Some teachers break it down. They just do a midterm and final. I like to break it into a little bit smaller pieces myself. That's all. Now, keep in mind, the final exam is what? 25. That would be rough. I've been in that situation. It's rough. How many of you plan on going to grad school? Alright. So my master's, instead of writing the paper, I had to take a test. And that test determined whether or not I got a master's. Even though I passed all the classes, one test determined everything. That was a stressful day. Very stressful. Okay. But as mentioned, that's what I thought it was the 15th. I don't feel we're gonna need to move it. All right. I had to condense some stuff given the storm, but I feel like we're still okay for that day. All right. Now, with that said, as we look at this problem here, make sure you see that the main thing that we're focusing on is the slope formula. But what number do both of these problems give us that we have to watch for? All right, do we all agree with that? We should always watch for zero, right? Zero is something that just kind of keep an eye on. For one, it could be an intercept, right? Hey, I got an intercept, nice. But here we're trying to find the slope. Now, in this situation, you see a zero. The next step is, can we do the division? Right? So for this first one, when you have 0 divided by -12, what does that equal? So we can do the division here, y'all. All right, 0 divided by anything is 0, so we're good. However, for the next one, what is -5 divided by 0? It's undefined. We cannot do that division. Right? Well, guess what? Up here, our slope is 0. Right? So at that point, we can just write the equation of our line. Because y equals what? Look at your points. What does y equal? Y equals 9, right? Now, you could use point slope form here. If you're not comfortable with that, just go plug in point slope form and you're going to get y equals 9. Okay, so keep that in mind. But what I want us to see here is that from the beginning, you could have caught that. Oh, hey, my y values are the same value for both of them. I should expect a 0 to occur here. Right? But that's the horizontal line situation that I said that come up. Whereas this next one then is the vertical line. Hence why the slope is undefined. It's like a cliff, right? A cliff, you try to tell me how fast the cliff goes down. Well, hey, it drops immediately, right? That's why they call it a cliff. With that in place, though, that means here you need to recognize right away that since your slope is undefined, right? If you need to write that out, m is undefined. You need to remember right away x equals -11. And I got that 11 from the fact that my x values were the same. Okay. That's definitely an important part of watching out for these cases. Now, are you always going to get a 0 here? No. Just know that when it happens, you got to watch for it. Any questions with those? Do we feel okay with the process, though, of finding the slope and then getting to the equation in general from the 4 problems basically I've done now? All right, so All right, so I have a pair of lines here that we need to be watchful for as well. These are both cases where I have two lines that we're comparing with one another. Okay. If I gave you two random lines, we should expect most lines will intersect one another. Right? This is definitely something to just kind of keep in mind. But sometimes we get this special case here. Right? Hopefully what you recognize is that these two, what my intent is they'll never intersect one another. So that means they have to be parallel. Well, based on what we talked today, what can we conclude must be true if the two lines are parallel? Did everyone hear that? So we have two equations here, right? We'll call it y equals m1x plus b1, y equals m2x plus b2. And I'm just using subscripts to make sure you see, hey, one comes from the first equation, the other. If they are parallel, which again, as I mentioned, that's my intent here, they will never intersect, so they're parallel. That means their slopes are the same. Definitely something we want to watch for and be aware of, okay? With that said, though, what do you think I mean for this one to be?
Probably opposite, or like.
A little bit more to it than just opposites. A little bit more to that than just a reciprocal. You're on the right path though, but if I'm calling this parallel, what's another special case that can happen?
Oh,
Perpendicular. Well, so we're gonna get there, right? But understand here, that's the other special case is perpendicular. And I put that little square there to say what's going on. What does that square represent? 90-degree angle, okay? It's not gonna happen all the time, right? These are special cases. If we just started randomly picking lines, more often than not, they're gonna intersect and they're not gonna be parallel or perpendicular. So when these special cases come up though, we wanna be prepared for, right? So parallel means the slopes are exactly the same. Well, if we look at this, what's gonna happen? If I call this line 1 and this one line 2, then the slope of line 1 has a relationship with line 2, right? It's an opposite reciprocal. So like I said, it was close to what you were saying, right? As far as the slopes are concerned, but it's the opposite and the reciprocal. So let's say that like line 1 was, say 3x plus minus 5. And we were trying to find line 2. Okay. Well, right away, we should say, hey, we know that the slope for line 2 is the opposite and the reciprocal. I changed the sign and I flipped my fraction. Well, I didn't have a fraction, so it becomes 1/3. Okay. This is definitely something you want to watch for. I know it definitely has a homework section on it. It's not necessarily a lot of problems I don't remember, but this is something that can happen. Okay. These are special cases though. Keep that in mind as well. These problems though, I like how they do because what they'll do is basically give you the slope right away. You then take the point you're given and go use point slope form to find the rest. So what you're seeing here is some of those problems, you'll exchange this part by recognizing what does it mean to parallel or perpendicular. The one thing you'll want to remember, if it's parallel, just take the slope you have. If it's perpendicular, just remember, hey, flip the fraction, change the sign. Opposite reciprocal is the way that we express that. Okay. Questions or concerns there? Like I said, I think that's a whole section by itself, if I recall correctly, from the assignment perspective. Has anybody still had trouble graphing on the assignments? All right, what are some issues that you run into?
Like I'll get the answers right, but then when I graph like the right answers I got, it says.
Let's see if I can pull it up on here.
And it keeps doing like.
How many points are you using?
Two. It's like whenever I use two, it says like it graphs the lines like.
Where's all my other stuff? What is this? Oh, it was worth it. There it goes. Oh. It was worth a try. Send me some messages though, like with screenshots of what you're looking at, so we can look at it. Pearson is a little particular. You have to make sure to graph by hand first though. So make sure when you're dealing with Pearson, graph your stuff by hand and then pick out the ordered pairs that are easy to work with, right? Try to avoid decimals and fractions as best as possible. It's not gonna work all the time now. Okay. And then use that perspective of, okay, which tool am I supposed to use? The reason I ask is for our class, I give us that virtual timing. Every one of those tools is 2 points, but you have to make sure to use the points in the order they're given to you. So if I like a quadratic, they plot that, what we call the vertex first and then any other point. So keep that in mind. Whereas with Pearson, I can't open it on my iPad, so I'm not gonna be able to show from this perspective. But with Pearson, the quadratic is 3 points. All right, so you have to plot any 3 points. I don't think there's a particular order or anything with that. So if you have trouble, you need to let me know so we can look at it. So kind of look at those problems and let's see if it's trying to get in the right spot or if it's just the tool issue. Okay, so I can make sure we fix that. Now, for the test, though, what am I going to expect you to do? If I tell you to graph though, and I have the sheet of paper with the coordinate plane on it, I'm expecting you how? Write it out, right? So make sure we write it out. That's the important part. Everyone understand that? So when it comes to the test, you need to be practicing drawing your graphs by hand. It's good to recognize them and be able to put them on a computer. But remember, as I said, the computer, the software is just there to check to make sure you had the right thing. Even then it's broken because there could be errors in the program. Like I know with the practice one I gave for the virtual day, it took me a while to write that code correctly, so it graded the problems correctly. There was a couple of years there where students were putting it was wrong, and I couldn't figure out what it was until I had some insight from others help me fix my stuff. Pearson probably has similar issues, right? So keep that in mind. Make sure we can draw it by hand though when it comes to dealing with the test. Any questions with that? Is there anything further I could clear up with the discussion today, talking about linear functions? All right, well, if you don't have any questions, have a good day. It is Tuesday, so if you're free from 12 to 1, we do have our lunch and Bible study that we do at the BCM here on campus. Yep. I'm a day off, so technically, but I don't want to keep squeezing stuff in if you don't have questions. If you have questions, I'm here for another few minutes.
I was like, and I see what you were saying. I was like, I was really doing
Online, it's okay though.
like, no one like, okay, I understand more, but I go to class.